we have solution to differential equation. The solution, which is otherwise called the primitive of a differential equation, is the relationship between x and y, which is free from derivative. So a solution to differential equation contains only x and y, and it doesn't contain any derivative. When I say derivative, I mean differential coefficient, the y by the x. Any equation that doesn't contain the y by the x, it contains only the relationship between x and y. Here, we manipulate the given differential equation so as to eliminate all the derivative present and leave only the relationship between x and y. So they will give you a differential equation which contains derivative. Your duty is to what? Manipulate the equation to eliminate all the derivatives so as to have only the relationship between x and y. So we have the methods of solving first order differential equation. So we have the first one by direct integration, by variable separation, homogeneous differential equation, that's by substitution, y equal to vx. Then the final one we have here is exact slash non-exact differential equation, though we still have some other method like the Bernoulli equation is still another method of solving first order differential equation. We still have linear differential equation, and there is another one called almost homogeneous. But as far as today's class is concerned, or what I want to cover right now is concerned, we're going to look into this ones. Maybe subsequent videos I might talk about those other ones. Okay, the first one we have here is by direct integration. Direct integration. Direct integration. All right. dy by dx equal to f of x. So any equation that can be written in the form of dy by dx equal to f of x. Now we have a function of x in the right hand side and we have derivative in the left hand side. It can be solved using direct integration. So sometimes you won't see it exactly this way, you can see it in some other form, but if you can be able to transform the equation to be in this form, definitely the only method that will bear the cat is by direct integration. Okay, so and then what we normally do is we'll cross change the x to this side. We have dy equal to f of x times dx. So we'll now apply integration on both sides. So the integral of dy is y, integral of f of x is still integral of f of x, then plus c, that's the arbitrary constant. So let's use a live example. Example 1. Solve the differential equation, and it is dy by dx equal to 3x squared minus 6x plus 5. And of course, the first thing to do is our solution here. Dy by dx equal to 3x squared minus 6x plus 5. So the first thing to do is to cross the x to this side, since this particular question is already in this form. Therefore, we can use direct integration. Crossing the x to this side, we have dy is equal to 3x squared minus 6x plus 5 dx. Then integrating both sides, as we say, integral of dy is y, integral of 3x squared is 3x cubed over 3 minus 6x squared over 2 plus with respect to x, and integrating is 5x then plus c. And we'll cancel out the powers, and the coefficients here will cancel. We have x cubed minus 3x squared plus 5x plus c. That's 2 divided by 6 is 3, and 3 cancels 3. So we have this. So this is the final answer. That's the final answer. So this is the solution which is independent of derivative. As you can see, we have the relationship between x and y, and there is no derivative, meaning the derivative that was in the question has been eliminated. So this is the solution which is only the relationship between x and y, which is independent of the derivative. Then what if the question was, if we give the y by the x equal to 3x squared minus 6x plus 5, giving that y is equal to 5 when x is equal to 0. Solve the differential equation. Solve the differential equation. This is exactly the same question I have here, but as you can see, an initial condition is accompanying this equation now. So not just to solve the differential equation, but we have an initial condition. So given that y is equal to 5 when x is equal to 0. So what we're going to do is we're going to evaluate c. We evaluate c using this initial condition and then find a solution, and that solution will now be called a particular solution. This one we solve here already. This answer here is the general solution. Then if an initial condition is given to you, then you are expected to find what we call particular solution. So it's a simple something. Start from that answer you got, which is, let's continue from there, which is y equal to, our answer is x cubed minus 3x squared plus 5x plus c. Then applying this initial condition, when s is 0, y is 5, that means y is 5 here, and when s is 0 cubed, and it was 3 times 0 squared plus 5 times 0 plus c. And then everything here multiplied by 0 is off, and then c is equal to 5. So we've evaluated the value of c. We're going to put it back to our original answer. So this is the value of c. When it is now 5, then the general and the particular solution ps is equal to the value of y, which is equal to s cubed minus 3x squared plus 5x plus c, and c is now 5. So it's a simple something there. So whenever initial condition is being presented, then you are expected to solve further, apply the initial condition to the answer you got. When s is 0, y is a given number, to find the value of c, after which you substitute back to the general solution to get what we call particular solution. Okay. We have some other example under direct integration. Example 2. Example 2 says x dy over dx is equal to 5x cubed plus 4. In this case, how do we make dy by dx to be equal to f of x? How do we make dy by dx equal to f of x? We can do that by dividing both sides by x. But we divide both sides by x, we find out that we're going to have dy by dx equal to 5x cubed plus 4 all over x. So x is affecting both the terms in the numerator, so that dy over the x will be equal to 5x squared plus 4 by x. As you can see, x divided by 5x cubed, 1x will remove 1x here, and then x going to the denominator as 4, we have 4 by x. So now we can cross multiply, so that we have dy is equal to 5x squared plus over x of the x. Then integrating both sides now. Integral of the y is y equal to integrating 5x, and 5x raised to the power 3 over 3 plus 4. Then we have the 4 is just the constant sum. Then we're interested in 1 over x. As you can see, 4 over x is same as 4 by 1 over x. 4 by 1 over x. So, right. So integral of 1 over x is ln x. So I don't need any revelation for you to know that. So integral of 1 over x is ln of x and close bracket. Okay, ln of x plus c. So this is my answer. So just know that integration of 1 over x, integral of 1 over x is ln x. So that 4 is just like a constant. We put it down here. Then the main function of x there to integrate is 1 over x, and the integral of 1 over x is ln x. So take note of that. So the answer is y is equal to 5x cubed over 3 plus 4 ln x plus c. So some other example on the direct integration. Let's watch this. Example 3. We have dy by dx is equal to 1 over x plus 1. So as you can see, dy by dx is equal to a function of x. So we can apply by direct integration. So we cross multiply so that dx will multiply that side. We have dy is equal to 1 over x plus 1 of the x. So by integrating both sides, integral of dy is y. Now, integrating 1 over x plus 1, that's a law I would love to share with you now. Then when you are about to integrate a function whose derivative of the denominator is equal to the numerator. Let me come again. Let me slow down. If you are about to integrate a function whose derivative of its denominator is equal to the numerator, as you can see, derivative of this denominator is 1. That's differentiating x is 1, differentiating 1 is 0. So derivative of this denominator is equal to 1, and 1 is the numerator. Whenever the derivative of the denominator equal to the numerator, then the integral of the general function will give us ln that denominator plus c. And since the logarithm function, it will now be plus ln c. You understand? So for instance, if I have integral of 2x over x squared plus 2 dx, if I want to integrate this, it's a very simple something. Just as this case I just explained now, differentiating the denominator will give me 2x, which is equally what I have up there. So what I will just write at the answer is automatic, which is ln that denominator plus c. That's how I write. That's the cheapest way to differentiate such. You just have to what? Observe. Okay. So we have y is equal to, of course, the log of logarithm. You take one of the ln function and then multiply the number within. So this is ln, this is ln. We take one, then addition means multiplication of numbers. We have c times x plus 1. So definitely this serves as our answer. Then the last example under this, example 4. Example 4, we have sine x dx plus dy equal to 0. So to solve by direct integration, you can see that we can just take sine x dx to cross to this side. We have dy is equal to sine x dx. Already that's negative sine x dx. Already we can integrate both sides directly. See, instead of it's not that this the x can still come there. So you can see if you bring this the x under here, you see that it meets the particular condition which we have been working with, the condition that says that dy, the condition that says that dy over the x has to be equal to f of x. So that is that. So we can integrate directly. We have integral here, and then we can say integral of dy is equal to minus integral of sine x minus integral of sine x dx. Okay, integrating dy is y equal to integrating sine x is minus cos x. Integrating sine x is minus cos x, so we have negative into negative cos x plus c. So finally, negative to negative is positive, so we can have our answer as therefore y is equal to cos x plus c. That is the final answer. Hope you enjoyed the video. Thank you, and if you've not subscribed to my channel, make sure you do so and click on the notification bell so that you'll be the first to see any video I am going to drop. The next topic I'm going to venture into is solving differential equation by variable separation. Solving differential equation by separating variable. Thank you and have a nice day.